Hello, here's the video for 7.2, Lesson 2 of Unit 7. So if you recall from the first lesson we did of Unit 7, we are talking about systems of linear equations, which essentially just means that we're talking about two equations or two lines on a graph. And the solution that we're looking for is where the two lines would cross on a graph. So we're looking for the point, the coordinate of where they cross. Now, method one that we learned about for how to solve a system was the graphing method. So in lesson one, we literally graphed both equations and then we looked at where they crossed and that point was our answer. Okay, lesson two is method two. And we are doing the substitution method today. So the substitution method is a way to solve the system mathematically without having to draw it, okay? So here are the steps you're going to follow every single time. Step number one, in either one of the equations, isolate either x or y. So as you can see here, you have two equations, and in each equation, you have an x and a y. So for step one, you're going to decide to isolate either x or y in either equation 1 or 2. You totally have the freedom to isolate whichever one you want, okay? Then number 2 says, take that equation that is now isolated, so the equation that you isolated in number 1, and substitute that into the other equation and solve. So once we take our equation from number 1 and substitute it into the other equation, what's going to happen is we're going to either only have x's or only have y's, and then therefore we can solve for that variable, and bang, we know what the y value would be of where they would cross. Then what we do is we take the variable we just solved for in step 2 and plug that into either equation to solve for the other variable. So this sounds super complicated, but trust me, once you see me do one, you'll be like, oh, that's a piece of cake. Okay, so solve by substitution. Here are your two equations. So step number 1 was to either isolate x or y in either equation. Now I want you to actually take a look at this and pick the easiest option. So you know that if there's a number in front of the variable, that you're going to have to divide off that number in the end, right? Like if you have 4y, you're going to have to divide that by 4 to get y alone, and you have to divide everything else by 4. And you have to be careful with that, because if you do that in this case here, you're left with a fraction, and fractions can get nasty, right? So always try to look for a variable that's all by itself, because you wouldn't have to divide by anything. So in this scenario, I'm going to isolate x in equation 2. So I'm choosing to isolate x in equation 2 because all I have to do to isolate x in equation 2 is swing that 2y over, right? Then I have x all by itself. On the right-hand side, that 2y became negative 2y because we flipped sides. And then this positive 2 just gets nudged down. So there we go. We have isolated x in equation 2, and step 1 is already done. Okay, then step 2 said, take the equation that is now isolated and sub it into the other equation. So we take this guy that is now isolated and sub that into the equation we haven't used yet. Okay, so we've already used equation 2. So that means we're going to sub this into the other equation we haven't used yet, which is 1. So this means that wherever I see an x in equation number 1, I'm going to replace the x with that, because x and this are the same thing. That's what the equal sign means. They are the same thing. So we can replace x with that or sub x in with that. That's why it's called the substitution method. And we're going to see something interesting happen. Okay, so step number 2 over here is I'm going to sub x with negative 2y plus 2, right? I'm taking x and subbing it in with negative 2y plus 2 in the other equation I haven't used yet. Okay, so here's equation number 1 in its original form, 3x plus 4y equals -4. Okay, so where I see an x, I now replace x with that. Okay, so I still have the 3, but instead of an x now, I have to replace x with what it's equal to, which is -2y plus 2. And then I recopy the 4y equals -4. Now, the reason this works and the reason this is cool is because now we have an equation with only y's in it, right? We replaced x with an expression that had a y in it instead. Now I have only y's. This means I can solve for y. And in the end, if I solve for y and isolate y, I'll get y equals something. And that something is the y coordinate of the point of the answer that we're looking for. Okay, oops. So I'm going to solve for y here, which means I have to distribute that 3. So it becomes -6y plus 6 plus 4y equals -4. I'm going to simplify these guys because they're on the same side. So -6 plus 4 is -2y. Then I still have plus 6 equals -4. I'm going to subtract this 6 to both sides so that -2y is now by itself. And on the right-hand side, I have -4 take away 6, so -10. To finalize the isolation of y, I divide each side by -2. So y is alone, and I get that y equals 5. So I know that in my solution now, that these two lines would cross at a point where y equaled 5. So our goal now is to find what x would be. And that's step 3. So step 3 said take the variable you just solved for, which was y, and plug it into either equation. Okay, so I'm going to take that y equals 5 and sub it in either there or there to solve for the other variable. I'm going to sub it into this one just because that equation looks a little bit simpler to me. Okay, so step 3 is sub y equals 5 into equation 2. Okay, so equation 2, of course, is x plus 2y equals 2. Now, instead of a y, I'm going to replace it with a 5. X plus 10 equals 2. I subtract 10 to both sides, and I get -8, right? -10, -10. So now, I know that my x value is -8, and there we go. That's where the 2 points would cross, okay? I'm just going to write that final answer near the bottom here instead. So my solution is -8 and 5. Okay? All right. Let's do another one now that we know the steps. So again, step number 1 is choosing to either isolate x or y in equation 1 or 2. Okay, so if you were in class, I'd say, what do you guys notice? I would say, make your lives easier. Don't isolate anything in that guy because in this guy, y is already isolated for you. So really, step 1 is done for us. So it's done for us. Y is already isolated, so we don't have to do a step 1. Okay, so step 2 means that we sub that value, 5 minus 4x, for y, right? Because it's y equals this time. So we sub that in for y in the other equation we haven't used yet, which is 1. Okay, so equation 1 is 2x minus 4y equals 7. So now where I see a y, I'm going to open up the bracket and substitute what y equaled over here, right? And that equals 7. Okay, so now I solve because I only have x's left in this equation, right? So I can solve for x. So I'm going to start by distributing this -4, and I get -20 plus 16x equals 7. I'm going to simplify those two guys because they're on the same side of the equation, and I get -14x minus 20 equals 7. Okay. Did I make a mistake here? Something isn't seeming like it's going to work out nicely. We might get a fraction. Let me just see here. So 5 minus 4, so 2x minus 4y equals 7. 2x minus 4, and then y is 5 minus 4x equals 7. So 2x minus 20 plus 16x equals 7. Oh, it's 2 plus 16. That's why. Sorry, guys. I knew something wasn't working out nicely. So I accidentally did 2 minus 16 here. It's 2x plus 16x. My bad. So it's 18x minus 20. That works out nicely now. I add 20 to both sides. I have 18x equaling 27. I'm still going to get a fraction here, but it's at least a reducible fraction. Okay. So if it's 27 over 8, I can reduce each of those by 9, and I get 3 over 2. Okay. So step 2 is done. I found my x value. So now step 3 is take that x value and sub it into either equation. So I'm going to sub x equals 3 over 2 into equation 2 because to me equation 2 just looks easier. Okay. So y equals 5 minus 4x, but I replace x with that. Okay. So I know sometimes we get worried when we, or we panic when we multiply, or when we see fractions, when we multiply fractions. Remember that that's over 1. Also, don't go 5 minus 4 first. We never do subtraction before multiplication. So we multiply those guys together, and that's over 1. So I now have 5 minus 12 over 2, right? 4 times 3 is 12. 1 times 2 is 2, which is just 6, right? So I actually just have 5 minus 6, and I get a y value of -1. Okay, so my solution here is that when x is 3 over 2, y is -1. And done. All right, last one. Okay, so I chose this one because when we do step 1, again, step 1 is choosing to either isolate x or y in equation 1 or 2. In both of these scenarios, we're going to have to divide something off, right? Every single variable has something in front of it, which means our final step of isolating will involve dividing, okay? What I usually look for, though, and this isn't necessary, but I see that these guys all have something in common, right? 4, 6, and 18 can all be divided by 2, so that I know that when if I do divide these guys somehow, that fractions would reduce nicer because they all have a 2 in it. I know I could divide out a 2 in the end, whereas up here, I have a 5, okay? And 5 has nothing in common with 3 or 18, so I know that in that scenario, I might have some fractions that don't reduce, okay? So that's why I'm going to choose this guy, but it isn't necessary. We're going to end up with fractions no matter what, but I'm going to choose number 2 here. And then you have to decide which one are you going to isolate, x or y? And it really doesn't matter. I'm going to go for x. So for step 1, I'm going to isolate x in 2. Okay. So to do that, I'm going to send him over. So I have 4x, and then on the right-hand side, that -6y became positive y plus 18. Okay. Divide off by 4, divide off by 4, divide off by 4. X equals 3 over 2y plus, and then here I can divide by 2, 9 over 2. Okay? And again, you could isolate y here. And actually, if you isolated y instead, I'm going to show you both options and you can decide which one you want to do. If we isolated y instead, we would send the 4x over. So I'd have a -6y on the left. I'd now have a -4x on the right and a positive 18. And then if you divide off by that -6, what happens is we have y isolated equaling positive 2 over 3x minus 3, because 18 over 6 divides nicely. So in this scenario, you're with 2 fractions. In this scenario, you're only with 1 fraction. Okay, but regardless, you're dealing with fractions anyway. So it doesn't really matter. But if you want to work with 1 less fraction, you could choose that one. Okay, But again, like I said, like my step says, I'm going to keep going with the first one I did, x. Okay. So step 2 is I take what x equals. So I'm going to sub 3 over 2y plus 9 over 2 into the equation I haven't used yet, which is number 1. Okay. So I take that number 1, which is 5x minus 3y equals 18. And where I see a y, I am going to sub it in with, oh, sorry, where I see an x, excuse me. Where I see an x, I sub it in with that, right? Because it's x equals this. Okay, so where I see an x, that goes in there. So it becomes 5, now open bracket, 3 over 2y plus 9 over 2, close it up, minus 3y equals 18. So all I did was replace x with that. Okay, so this is where I'm at. So what you need to do is distribute this 5 in, okay? And then after that, we're going to get rid of the fractions. We can't really get rid of the fractions now because they're inside a bracket, okay? So we have to distribute that 5 in first. That's going to be easier. When you distribute the 5 in, remember that this 5 is really over a 1 only. So that 5 just gets multiplied to the top numbers, just the 3 and the 9. The 2's on the bottom will not change. So we get 15 over 2y plus 45 over 2 minus 3y equals 18. So now that those brackets are gone, I'm going to get rid of the fractions. The denominator is 2, so 2, 2, 2, 2. I have to send it to everything. I have to be fair. Okay, so 2 over 2 cancels, and I have 15y plus 2 over 2 cancels, 45, minus 6y equals 36. I'm going to simplify these guys because they're together on the left-hand side. That's 9y plus 45 equals 36. I'm going to subtract 45 to both sides. So 9y is alone, and 36 minus 45, what's that? 9. And, oh, sorry, negative 9. And then we divide off 9, y equals negative 1, and I have found my first value. Okay, so I found y first. Now, the final step is to take that and plug it into either equation. Okay, so I'm going to plug it into, number 1, doesn't matter. Both 1 and 2 are equally complicated. So I'm going to sub y equals negative 1 into 1. All right, so 5x minus 3y, but y is negative 1, equals 18. So I have 5x plus 3 equals 18. Let's take away that 3. I have 5x equaling 15. So I divide off by 5, and I get that x equals 3. So my solution then that you always have to give me is that these two lines, if we were to draw them, would cross there. Okay? And that's the substitution method because we're constantly subbing things into the equations. All right? So to follow this, there's a worksheet here, and I gave this to most of you when you were in school last week, but if I missed you or you were gone, here it is. If you don't have a printer, that's fine. You can just write these down on a sheet of paper, and the solutions are at the bottom. Good luck.